My name is Nathan Motherai, and I am an assistant professor in the Division of Neonatology at Johns Hopkins Children's Center. I'm grateful to be able to speak with you today about research we've been doing in the Jancy Lab to better understand the impact of prenatal exposure to opioids. The public health crisis of the opioid epidemic extends to infants and children who are exposed to opioids in utero. The care of infants with prenatal opioid exposure focuses on initial withdrawal symptoms, which we characterize as neonatal opioid withdrawal syndrome, or NOWS, with much less attention given to the long-term impact of prenatal opioid exposure. There's been growing concern that prenatal exposure to opioids affects the developing brain and leads to consequences that may only be recognized as an infant grows into toddlerhood, school age, or adulthood. Emerging clinical literature has demonstrated greater risk for long-term neurodevelopmental consequences in children with prenatal opioid exposure, including attentional deficits, motor dysfunction, and cognitive differences. However, there is still a limited understanding of how opioid exposure causes long-term injury in the developing brain. In this review study, titled Sex Differences in Neonatal Outcomes Following Prenatal Opioid Exposure, we explored the crucial role biological sex plays in outcomes related to prenatal opioid exposure. Sex is a biological variable that plays a fundamental role in the effects of the endogenous opioid system on critical functions, such as neural cell maturation and differentiation. Exogenous opioid exposure, including prenatal opioid exposure, also leads to sex-specific variation in the development of neural pathways, gut microbiota, and hormonal regulation. While studies show significant biological plausibility for the influence of sex on prenatal opioid exposure and childhood outcomes, we still need more substantial investigation into the sex-specific mechanisms underlying this influence to drive tailored management of infants affected by prenatal opioid exposure. Gaining better understanding of how opioids influence the developing brain is crucial to improve the health and well-being of infants and children affected by the opioid epidemic. In the Jancy Lab, we've endeavored to answer this question using a well-established and translational animal model of prenatal opioid exposure. We've found significant inflammation and immune system disruption in animals with prenatal opioid exposure, alongside long-term deficits in behavior, attention, gait, and cognition. Our next steps are to translate this work to neonates with prenatal opioid exposure, with the goal of better understanding how opioids impact the developing brain to help inform management, treatment, and long-term follow-up of infants and children exposed to opioids prenatally. Thank you for listening. I would like to thank Lauren Jancy and Elizabeth Yen for their support and mentorship. I'm grateful to my colleagues in the Jancy Lab, the Robinson Lab, and in the Division of Neonatology at Johns Hopkins for the tireless work they do every day to push forward for the health of infants and children. Thank you.